Rigging is a technique that allows an animator to deform and animate a mesh by moving the underlying skeleton. In this tutorial, I will be creating a simple leg rig to introduce you to the fundamentals of rigging. First, I will create a cylinder and scale it vertically before adding a few more subdivisions. Without these additional subdivisions, it will be difficult to deform the mesh effectively. To add subdivisions, go to Inputs, click on Polycylinder, and modify the subdivision height field. Next, we will go to the side view by hitting the spacebar and create a joint chain. Before you create joints, before you access any of the rigging tools, you must make sure that you change the menu from modeling to rigging. Once the menu has been changed, you can select the skeleton tool, the second tool, and create a series of joints. Currently, I'm not able to see any of the joints because the cylinder is hiding the joints. So I need to go into shading and click X-ray. Now you'll be able to see the joints as well as the mesh. When you click, when you select the joint tool and create a joint chain, the first joint that you create forms the topmost node in the hierarchy, and the last joint forms the last node, the child node in the joint hierarchy. When you create a joint chain for an arm or a leg, you want to make sure that you create a slight angle in the direction of the bend. This prevents the joints from flipping once you begin to animate the skeleton. Before we go any further, let's go to the front view and make sure that the skeleton is properly aligned. I'll hit the space bar, go to the front view, and click on X-ray to make sure that the joint chain is inside the mesh. You don't want the joint chain to be outside or in some other location. Now we go to the perspective view and we attach an IK handle to our joint chain. Creating an IK handle allows us to position the joint chain backwards from the end joint. This is similar to positioning a person's elbow and shoulder by holding and moving the wrist. So let's double click on the IK handle tool, the third option, and make sure that from the drop down we select Rotate Plane Solver. The rotate plane solver allows us to twist a joint chain, making it easier for us to produce complex animations. So click on the root joint first, this being the topmost node, and then click on the last joint in the chain. And this should create a an IK handle which will allow you to move the joint chain from the end joint. Next, we create a control handle and attach it to the IK so that it is easier for us to select, move, and set keyframes to the IK. To create a control handle for our IK, we will create a NURBS circle. Click on Curves and Surfaces and then select the first option, that's circle, and then scale it up a little. To make sure that the circle is in the right location, I'm going to hold down the V and drag it to the last joint, which will snap the circle to the joint. So I'm holding down the V key and then simply dragging it to the joint, which will snap it to the last joint. Before we attach the circle to the IK, we need to zero out the XYZ values associated with the circle. This will make the current location of the circle its base position. While animating, if you want to reset the position of the rig, all you have to do is zero out the XYZ values of the control handles. To zero out the XYZ values, go to Modify, Freeze Transform, or Freeze Transformations, leave the way it is right now, and then say Freeze Transform. And as soon as I hit Freeze Transform, you will notice that all of these values up here in the channel box will turn to 0. Now this location has become the base location for the control handle. Next, I'm going to go to Windows, open Outliner. In the Outliner, you see all of the assets that we are currently using, which includes the IK handle and the NURBS circle. What we want to do is middle mouse click on the IK handle 1 and then drag it inside the NURBS circle. Now, if you select the circle, it will also select the IK, and now you'll be able to move the chain up and down, and bend it. The last step involves attaching the mesh to the skeleton. First, we select the mesh, then we select the topmost node or the root joint in our joint chain, then go to Skin, Bind Skin, and then click on this little go to Skin, Bind Skin, select Joint Hierarchy, and then select Bind Skin. Now, if you select the control handle and move the joint chain, you notice that the mesh deforms with it. Now, once the skin is bound to the skeleton, you need to make sure that the joints deform the mesh correctly. We do so by determining which joint has how much influence on which part of the mesh. To see how the joints influence the skin, double click on the Paint Weights tool under Rigging, which is right here, and then select the mesh or click on the joints and see which of these joints are influencing which parts of this mesh. The region that turns white is under the influence of the chosen joint. For example, if I click on joint 2, then the white area, the gray area is what that joint is controlling. If I click on joint 3, then that's the area that joint 3 is controlling, the area that turns white. Sometimes what happens is that multiple joints have influence over the same region, which causes undesirable deformations during animation. To avoid such undesirable outcomes, we need to take away influence from certain joints. For example, when I select joint 2, everything below joint 2 turns white, but this area right at the bottom edge is gray because joint 3 still has influence over that joint. Now, the best way to fix this issue is not uh, by painting black on these areas. Rather, what you do is you go to joint 2 and then add more influence for joint 2 for these regions. And you do so by clicking on add and then making the opacity and value 1, which means that your slider is all the way to the right, and then you paint that area with opaque white. Now, if you go back to joint 3, you will notice that the area that was white previously is now dark. You notice that there are still some gray areas right down the middle. So what you do is you go back to joint 2 and once again paint those areas white, which will take away the influence from joint 3 and give it to joint 2. So now if you go to joint 3, you'll notice that there are no gray or white areas except at the very bottom, and you can fix that once again by going to joint 2 and painting that area white. Now if you go to 3, everything looks black, which means joint 3 has no influence over any part of this mesh. Now if you deform the mesh, it still works just fine, except the entire region, the lower half of this leg is driven by the knee.